All right, so we're looking at fractions review still, and we're looking at moving on to improper fractions. All right, so let's do a little review on what this means. So name the fractions that are shaded. So how many parts are shaded in each one, and how many parts are in the whole? So I just want you to pause and just think about it for a second, but this should come to you hopefully pretty quickly. Okay, so they are all one whole. Okay, so if I'm looking at this first one here, it has 4 pieces, right? So it's out of 4, but all 4 pieces are shaded. Okay, and that is one whole. Okay, so the way that we can prove this fractions, if we want to change to whole numbers or mixed numbers, we take the denominator and we divide that into the numerator, and then we come up with the whole, right? Or we take the numerator and divide it by the denominator. And 4 divided by 4 is 1, right? And we can see that visually here. Second one, same thing. We got 6 over 6. Okay, so that is equal to 1 whole, right? Here, what would you say it is? So I'm going to say here, there's 9 pieces in total, right, of this triangle. And it is 1 whole. So what would the top number be? Exactly, it would be 9 over 9, which is 1 whole. We've eaten the whole entire thing, or we've given the whole entire thing away, right? This one here, 1 equals, and the denominator is 7, because that's how many pieces we chopped it into. But how many are shaded? Absolutely, 7 out of 7, so the whole entire thing is shaded. So 1 whole thing is shaded. Okay, so looking at this, these are equivalent fractions. Okay, so they're exactly the same size. I know that because I cut and paste them myself. All right, so if I'm looking at these, I know that I have 2 wholes here, right? There's 2 wholes there, right? Or if I'm going to write this as a fraction, they're divided into pieces that have 2 in them. Okay, and then I have how many pieces? I have 4 pieces, right? All right, so I have 4 over 2, and I can prove that it's equal to 2 because I can take 4 and I can divide it by 2, and I know that the answer is 2 because 2 times 2 is 4, right? All right, now again, we're looking at this one here, and I'm telling you that it is equivalent. So it's equal, it's the same. So it's like putting here and this side is equal to this side, right? It's equivalent. So I know that I have 2 whole pieces, but one is cut into 3 pieces, and then I have 6 pieces in total. Okay, so if I say that this is my pizza, each pizza is going to be cut into 3 pieces, right? And I have 2 pizzas, and I have 1 is cut into 3 pieces, and then I have the total of 6. So this is kind of where people start getting a little bit confused with fractions. So hopefully I'm doing a good job of explaining it to you. And then if I take 6 and I divide it by 3, it proves that it's 2 because it divides into 2, right? 2 times 3 is 6. All right, I want you to pause the video, and I actually want you to do these, okay? So if we look here, if I look at this bottom number and I compare it to the top, and I look at this bottom number and I compare it to the top, okay? The top number is double the bottom number in both of these cases, and I'm telling you that is going to be true with all whole number fractions that equal 2, okay? So if I'm looking at this first fraction here, okay, now it is 2 wholes, right? And they're divided into 4 pieces, but how many pieces are there in total? So I know that there's 8. And this is important because when you're having a party and you're needing to cut a cake, or you just need to know, or how many pieces of pizza you need to know how many pieces you need to be able to get, right? All right, so again, I have 2 whole pizzas, and they're cut into very, very, very small pieces, right? 42 pieces. And so how many pieces are in total? Well, 2 times 2 is 4, and 4 times 2 is 8, right? All right, so looking here again, so I'm just going to double this bottom number. 7 doubled is 14, 60 doubled is 120, so I know it's 134. All right, now we're looking at the numerator. So this is how many pieces there are all together, but we know that we have 2 pizzas. So I'm going to divide that 10 by 2. Okay, remember our fact family triangles, right? 10's up here, 2's over here. We don't know what this is, so I know I go 10 divided by 2 equals, and I know that that is 5. Okay, so same thing if I was given this number instead, I would have known that 10 times 2, or 5 times 2 is 10. Okay, so looking here, I have 62, and I know I have 2 whole pieces, so 62 divided by 2. Okay, 60 divided by 2 is 30, and then 2 divided by 2 is 1. Okay, so I really hope this is making some sense to you. I do want to ask, how are these fractions different from the ones that we've already looked at? So again, these ones are called improper fractions, right? Because the numerator is bigger than the denominator. Okay, now what if I had a fraction that looks like this? Okay, just a regular old fraction, 2 over 4, 2 or 2/4. Okay, what do you think this would be called when the numerator is smaller than the denominator? Okay, it's called a proper fraction. Wasn't a trick question. Okay, so how many pieces are shaded? All right, so there's 9 shaded pieces. Now, if I look at my 1 pizza, how many pieces are there? So there's 4 pieces. So if I'm going to write this as a improper fraction, right, I'm going to write it as 9 over 4. But what if I wanted to write it as a mixed number? How would I figure out what that is, right? So again, I know that 9 is going to be the biggest number, and 4 there, and I know I can divide, right? And now this isn't going to be even, so I know that I have 2 full pieces, right? Like, and it's always really important, like if you're not really understanding, draw the problem out. Mathematicians make their mathematics visual. Every mathematician in the world draws their problems out. So don't feel like you shouldn't be drawing these out, because 100% you should be. Okay, so I know I have 2 full pieces, right? And this is proven when I divide 9 by 4, right? I'm going to get 8 there in the beginning. So I have 1 piece left over. Oh, I have 1 piece left over. Right, and so instead of having that as a decimal remainder, we just keep it as 1/4. All right, so let's go a little slower again. All right, so we're just going to do improper fractions, because we are going to get into doing them back and forth and moving them from improper fractions to mixed numbers and back, but in the next video. Okay, so if I'm looking at this, how many parts are shaded? Okay, that would be our what? Is it going to be in our numerator up here, or is it going to be in our denominator down there? So yes, how many pieces are shaded in total are going to go on the top, right? So I have 7 pieces shaded, and then I have to look at just in one hole, how many pieces is that cut into, right? So that is cut into 4 pieces, okay? So one pizza is, and one piece of that pizza right there is gonna be 1/4, right? And so how many 1/4 pieces are there? So there's 7 1/4 pieces. And that's kind of what we're asking. So we're like, oh yes, we have 7 of them. So I know that I can have about 8 friends over that are very late eaters. Okay, so some triangles here, and I can't think of what you would eat or what you'd do with a triangle. So we're just gonna pretend this is triangle pizzas. Okay, so, because you have a fun parent that makes you triangle pizzas. All right, so I have, how many pieces are shaded in total? So I have, these are marked into halves, but I have 1, 2, 3, 4, 5 halves, right? And now if I just look at my 1, they're cut into 2 pieces in total, okay? All right, so how would I color this in if I want to show 15/6? So just pause the video, and I want you to just, you don't have to draw it in your notebook, but I want you to just picture, how would you color this? All right, I like my sparkly pen, so I'm going to use my sparkly pen. So each one of these is 6, right? Which is why the denominator is represented by 6. So I can scribble this in, okay? So that's 6. I count by 6s here, 12. And then I go 13, 14, 15. So I know that I can just color half of this guy. Now, why did I give you too many? Because I wanted to make sure you knew where to stop. Okay, so this would be 15/6 or 15 out of 6.